I think I am live now. Can anyone confirm if the audio and everything is fine before I get started? Hello? Okay, I will start with problem A first. Okay, thanks, Deepu. Voice is clear, right? Okay, yeah. Thanks, Deepu. Okay, problem A scoreboard. Like Team Takashi and Team Maloki play N matches. The ith match, the Team Takashi scores XI points and Team Oki scores YI point. The team with the highest total score from N matches win. Print the win. If the two teams have the same total score, it's a draw. Here we are given an array, n we are given n pair of integers. Like score one integer is score of team Takashi, one integer is score of team OK, and we have to find the total score of both of them and compare which one is higher. And if it is equal, we should print row. If we look at the first sample, in the first sample, if we look at the scores are 10 2, 10 1, 10 2, and 3 2. If we compare the total score of both of them, like one of them has total score 33 and one of them has total score 7. So we can compare these and print the winner of accordingly Takashi. Similarly, if we compare the score in the second sample, it is 5 4, 4 5, 2 4, 1 6, 1 7, 3 2. And if we take sum of both of them, we will find out that the scores are equal in this case. And we should print a draw. And similarly, we can look at the third test case. Jumping onto the code for this problem, we can to score the second team, and then we can run a for loop n times. We take score of the first team and second team, add the score of first team to the first variable, add score of second team to the second variable, and now we can compare. If the score of first team is greater than the score of second team, we should print Takashi. If the score of first team is less than score of second team, we should print OK. And if the score of both the teams are equal, we should print draw. Any questions on this one? I will take up the questions after the problem B. Problem B says extended ABC. We define extended strings A, B, and C, and extended string ABC as follows. A string S is an extended string A if all the characters in S are A. If a string S is an extended string B if all the characters in S are B. A string S is an extended string C if all the characters in S are C. And the string S is an extended string if there is an extended string A SA, extended string B SB, and extended string C XC, such that the string obtained by concatenation of SA, SB, and SC is equal to S. Now we are given some examples. A B C A B B C C C are extended strings, but A B A C and B C C A are not. Note that empty string is an extended string and is an extended string A, B, C, and an extended string C. You are given a string consists of characters A, B, C, If the S is extended string, print yes, otherwise no. Like there are some definitions over here. Let's look at each of them. Like first it defines like extended string SA is a string which contains only of characters A. And the count can be any. Even the count 0 is allowed. So an empty string is allowed to be an extended string. Extended string SA. Similarly, it says extended string SB is the string which contains only B any number of times. And like number of times can be 0 as well. So empty string is also allowed to be an extended string. Similarly, SC is a string which contains C any number of times. Even the 0 times that is empty string is allowed. And now it also says the extended string ABC. Extended ABC is a string which contains first an extended string A, then it contains an extended string B, and then it contains an extended string C. Now there are some examples given as well, and in the problem statement we are given that there is a string S which contains only of characters A, B, and C, and we have to check if it is extended or not. One important thing to note is like if a string is like this, then it can only contain A, B, and C. So had this constraint was not given to us, then we would have to like instead of saying that the string S contains only characters A, B, and C, had it was written that it contains only lowercase Latin letters, then we would have to also check if the string contained any character other than A, B, and C, and we would have to print no in that case. And if we look at the structure of extended string, like there would be first some number of A's, that count can be 0 as well, then some number of B's, then the count can be 0, and then some number of C's, and the count can be 0. So if you look at an extended string, it will contain first some number of A's, that count can be 0, then it will contain some number of B's, that count can be 0, and then it will contain some number of C's, and that count can be 0 as well. So like we can do some things like we can try to split strings. Like we can first try to find like how many initial A characters are there, and then we can also try to find like how many last characters C are there, and we can if we remove both of these strings, then only extended B string should remain. So we can check if the string contains only B after that. Or the other way around, what we can do is we can maintain a pointer idx, start with 0. We run a while loop until we find equal to A, idx plus plus. And also obviously the condition idx x less than size len n, where n is length of A. Then we run a while loop. Idx should be less than n, and s of idx should be equal to B. Idx plus plus. The idea is here we are greedily trying to find like the longest possible extended string A which can be in starting. Then we are trying to find like the longest string extended string B which is present just after the longest A. And then we can run while idx is less than n and s of idx equal to C, idx plus plus. And after all of these loops are completed, if idx is equal to length of s, then print yes, otherwise print no. Because what we can say is like if we follow this algorithm and if it's the extended string, then after this the our final string would complete the compressed string. Yeah, like there are many other solutions as well. Like as Rajiv mentioned, compress the string into ABC and the final string must be of form ABAC AB. Like that's one idea. And the other idea is like check if S is sorted. That also works. Like in the contest I did if S is sorted. And like this was the idea which I would say the simplest one which you can try it out. Like Now I will jump on to like what actually I coded in the context. I was just checking if the string is sorted, and for that I have checked like si is greater than like if a larger character appears with before the smaller character, then print no return, otherwise print yes. But if you follow this pseudocode as well, like maintain a variable index I and keep it increasing the index as long as it's a, and idx is less than the length of string, then keep iterating until you have an index b and idx is greater less than n, and then keep iterating until the character is c and idx is less than n. I will add the original code for this one after the contest, like after this stream in the chat as well, in the comments. So like that was the main idea. Any questions on A and B before I move on to the next problem? Moving to problem C now. Like there are many ideas to it. Like let's read it up. It says there are n people standing in a line, person one, person two, and person n. And you are given the arrangement of people as sequence A1 until AN of length n. AI represents the following information. If AI is -1, the person I is at the front of the line. If AI is not -1, then the person I is right behind person I. Print the people's number in the line from front to back. And like one important constraint it says is that there is exactly one way to arrange n people consistent with the given information. Like let's look at the sample for this problem. Like in the first sample we are given like the order is 4 1 -1 5 3 2, and we know that the where AI is -1 would be the first person in the length. So we know that first person in the sequence would be 3. And now looking at it, we know that the person right behind 3 is this one, which is 5. And after this, if we look at the person right behind 5 is this one, which is 4. And now if we look at like the person who is right behind 4 is this one, 1. And if we check the person right behind 1 is this one, which is 2. And the person right behind 2 is this one, 6. The way we can do is when we are first we take input, and then we can first find the index where AI equal to -1, and we can maintain a first which is I. Like we can maintain a variable first who would be at the first position by checking who is at the point -1, and then we also maintain a variable next who would be the person just behind AI. For example, if AJ equal to I, then we say that the next person after I would be person J. So like first we can find who is the first person in the line by checking which point has AI as the -1 and make it the first variable. And then we can try to find like we can also run a for loop. Then first person is I, else next of AI is I. First we can run a for loop like this. And using this for loop, we can find who would be the first person in line, and for each person, who would be the person just after it. And after that, we can maintain the current line, current person, first person, and run a while loop. And we can initialize the next I equal to -1 first. So like for the last person, the next person would be -1, a flag like this. While current person is not equal to -1, print current person, and then find the person just after it. Like I know my handwriting is a bit bad, but like that would be a pseudocode for this. Like that was one idea for it. Like the other idea I did in the contest was we can maintain and directed edge. Like we can maintain a directed edge from AI to J. Sorry, AI to I, not J. I. This graph will contain n minus one lines and minus one. Like we can ignore where AI is minus one. And then there is something known as topological ordering. Like in a strongly connected component, like topological ordering is defined as a sequence of pair of nodes such that each vertex is exactly in one of the list, and each list of vertex corresponding to the order of list is undefined, and the list of vertices is sorted in topological order. That is, one second, let me look at the better. Topological order is defined as topological order. Yeah, like topological sorting is defined as like you are given a directed graph and it can be acyclic or cyclic, however you want, such that like if there is an directed edge from topological order is defined in a directed acyclic graph, a graph which does not contain any cycle, such that the you are given an order a1, a2, a3, a4, an. Like this is the sorted order, such that if there is an edge from u to v, like for every edge u to v, like u would come first in this order before v. So if you look at in a way, like if you create an edge from ai to I, if you try to find the topological sorting order for each of these, then like the topological order will ensure that ai comes before I in this. So you can directly use if you have some topological order graph as well to print it. In the contest I did with the topological order idea because this function was present in Atcoder library and saved some line of code. Like take the order if x is equal to 1, otherwise add an edge from x to y. And at last print the topological order nodes. Like I will add the pseudocode which I have shared as a code after this in the comments as well. So like that, this was problem C. To problem D. Like problem D says there is a grid. Like any questions on C before I move on to problem D? So like problem D says cheating Gomoku Nabare. I don't know what does this mean. What we are given is there is a grid with h rows and w columns. Let ij denote the cell at ith row from the top and jth column from the left. Each cell contains one of the characters O, X or dot. Okay, like how to see all problems, you can just click on task for printing. Like each cell contains one of the characters O, X and I. The characters written in each cell are represented by H strings. Basically, we are given a grid which contains these three possible characters over here. And then for this grid, you can repeat the following operation any number of times, possibly 0. Choose one cell with characters dot and change that cell to O. And what we have to see is like if it's there is a possible sequence such that they are k horizontal or vertical consecutive cell with O written in all cells, and like there is some formal definition given. Yeah, like that idea also works R2M. Like see which index is not present and do it in the reverse line and print the reverse. Like that will work. So like to summarize like problem C D, like let's look at like what exactly, let's look at some samples first. Like for example, in the first character, we are given sequences cross O dot cross dot dot O dot cross cross dot O. What we have to see is like K is 3 over here. Like we should, like after changing some dot to O, either we should have 3 equal characters, a pattern like this in the horizontal side, or 3 equal characters, a pattern like this in this case. And it says the answer is 2, and we have to find the minimum operation such that a pattern like this or a pattern like this appears. For example, in this sample, we can change this dot to O and this dot to O, and this is a valid answer. And the other possible way to do is like we can also change this dot to O and this dot to O, and now we will have 3 characters like this. And this is also a valid example. We can also change this dot to O and this dot to O, and now we will have 3 consecutive characters. Like this is also a valid way to do it. We can also do it the other way. Like first we can change this dot to O, then this dot to O, and then this dot to O. Now if you look at this, like this will also have 3 consecutive characters. The problem here is like this is not the minimum number of operations. Like this idea took 3 ways, but we know like if we do it like this, then we will have only 2 equal characters. So like if we try to do it, like let's try to solve a simpler problem first. Instead of doing a grid, let's say we are given a straight line dot dot, we can change some dot to O, and like we have to count the minimum number of operations such that there are at least k consecutive characters which are O. If we can solve the problem for this one, then what we can do is we can take the original grid, we can look at the all the horizontal strings and find the minimum operations for each of them and take it minimum with the answer. And we can also look at all the vertical strings and take minimum answer for each of them. And like if we are trying to solve a horizontal grid, what we can do is we can also use prefix sum idea. We can replace each x by an infinite cost. Like let's say we have to, let's assign the cost for each change. We say that we can change x to like we can change O to O in 0 cost. We can change dot to O in with cost 1, and we can change x to O with cost, let's say, infinite. Then if we want to look at the consecutive cost for these characters, then we can just take the prefix sum to find like the cost to change these to O minus the cost to change these, and subtract both of them to find the cost to change these characters over here. And if the final cost is greater than equal to like let's say infinite, then we say that it's impossible and print -1 instead. Like that was my idea. And if I look at the problem D, like I first took the complete array as input, assigned answer as the infinite cost. Like I first solved for all the horizontal strings, which I can do directly iterating over here. And then I went for vertical loop for j equal to 0 to m, a string s, and I found s by doing this part, like I from 0 to n s plus equal to this character, and then solved for s as well. And if the answer is greater than k, because like that's essentially checking if answer is greater than equal to infinite, take answer as -1. And now for a fixed string s, if the length of s is less than n, return 0, like we can never find it. Otherwise, I am maintaining a prefix sum array where like current cost is 0 if s is equal to o, current cost is 1 if the s is dot, and if x is x, like I just said, current cost is k plus 10. You can take infinite or anything you want. And then a prefix sum, like add it back, like this is the prefix sum cost idea. And then I'm running a for loop from I equal to 0 to I plus k, and like the sum of cost of k consecutive characters, difference of them, and take it minimum with the answer. Like that was the idea. Like any questions on this one, like before I move on to the next problem? So if I move to problem back, this is an interactive problem, a type of problem where your program interacts with the judge program through standard input and output. Like I am sure like I have seen this problem before, and since it's an Atcoder beginner contest, it was given to probably introduce you with the interactive kind of problems and like how to solve it. There are n bottle of juices numbered from 1 to n. It has been discovered that exactly one of these bottle has gone bad, and even a small sip of spoiled juice will cause stomach upset the next day. Takashi must identify the spoiled juice by the next day. To do this, he decides to eat minimum necessary number of friends, to call minimum necessary number of friends, and serve them some of the n juice bottles. He can give any number of bottles to each friend, and each bottle of juice can be given to any number of friends. Print the number of friends to call and how to distribute the juices, and then receive the information on whether each friend is upset the next day and print the spoiled bottle number. So the main idea is you invite some of your friends, you give them some of the juice bottles, and then you look at like who all had gotten stomach upset the next day. And if you look at all the bottles which were common in all of those peoples, and you know the answer would be one of them. Like for example, you call, let's say you called three friends. In the first friend, you gave bottle 1 and 2. To the second friend, you gave bottle 2 and 3, 2, 3 and 4. And to the third friend, you gave bottle, let's say, 1, 2 and 4. Yeah, like sliding window will also work. And let's say after, like, you have four types of juices. After the first day, you know that everyone got upset, like everyone had a vomit or something like this. Then you look at like which number is common in all of them, which is 2. So you know that the juice 2 must be one of them. And let's say you receive the information like only second friend got upset, then you know that 3 is the only number which is common in all of them. Like the number which is common in all the friends which were got upset or like got a fever or something, and that number should not be present in all the remaining numbers which did not get upset or like got a fever or something. Like in this case, like all the 2 8 2 3 and 4, but 2 bottle 2 was also drink by first person who did not got a fever or something like that. So like the 2 cannot be an answer, and 4 cannot be an answer because 3 also ate it and he did not got an upset. Similarly, like if bottle 4 was the one, then you know that like 2 and 3 both would be the ones. If the bottle 2 is there, 1 2 and 3 all of them would get a fever. If bottle 1 was the case, then only 1 and 3. Like, and now there are many possible ways to do it. Like one idea to do it was like if we look at the numbers index 0 in the binary representation, like 0 1 2 3 4, then the binary representation of 0 is like this. And we know that the AND of any two numbers Yeah, I am going to give bi-weekly. Like the idea was like if we represent every number in the binary, then no two numbers which are not equal will have the same binary representation. So like what we can do is like we can look at the bit 0, and everyone who has 1 in their binary representation at bit 0, we give those juices to the first friend. And everyone which has 1 in the binary representation, we give that to the second friend. And everyone who has 1 in the binary representation at the second bit, we give it to the third friend. And like after that, all the numbers are 0, like so we will not give any bottle to all of those friends. And after that, once we know like which all friend got angry, then we can look at like which was the common number between each of them, and we can uniquely identify that by looking at the binary representation. Like based on like we can see like what is the binary representation of S, and if the first friend got a fever, then the binary representation would contain 1. If the first friend does not contain, then the binary representation at index 0 would be 0. Like basically if we give that I idea, then if the ith friend got fever, then the binary representation at the ith bit is 1. And if the ith friend did not got fever, then the binary representation at ith index is 0. So by just looking at which all friend got fever, we can find the final number back again over here. And like that was the main idea. And like I will quickly jump onto the code for this one. The thing is, I also want to discuss problem G in the next 10 minutes. So like I will try to rush it a bit. I'm pretty sure it has a name, like Rajesh says is brain cellar puzzle. Like I don't know the name, but I'm pretty sure like this idea has been asked many of the times. So like first I looked at like how many bits like the n number n minus 1 contained by looking at b plus 1. So, and then I printed the count of friends and iterated over from all the bits j equal to 0 to b, and like an array a which contains like all the friends which should get this I equal to 0 to n. If the ith bit is 1, like this is a sort form, add that friend to our current array, at last print the size of array and print one index those friends. Now take s as an input back and like iterate on it. If the ith jth bit is 1, then add 2 to the power j to it, and like since it's one index, print answer plus 1 back to it. This was the idea for this one. Like I wrote a lot of code for f, but I was not able to get an AC on it. Tree inversions. Like any questions so far? So like the last problem, tree inversion. Like this is you are given a tree T. N vertices 1 to n. The ith edge connects ui vl, and for a vertex v in the tree we define f of u as the number of pairs v and w in T such that the following two conditions met. V is less than w and the vertex w is in path from u to v. Like for example, let me take the given sample. Like for example, let's draw the given tree first. Let's say we want to find the answer for 4. Then we look at all the paths, like all the pair w and v, such that v is less than w, and from the path from 4 to v, W is in on this path. Like for example, one possible choice is like if we look at this path. In this case, like we can take as a node, W as a node 2 and V as a node 1. So on the path from V to W, like the final node 1 is less than 2 over here. Like on paths from like 1, 2, and 4, if we take W as 2 and V as 1, like then on path from 4 to V, which is 1, like W exists and W is less than 2. While for example, W equal to 3 and V equal to 1 is not a valid choice. Although W is greater than V, but W which is 3 does not exist on the path from 4 to 1. And like similarly, we have to count for each node. Like for example, if you look at like 6 and 7, like W equal to 6 and V equal to 7. Although like W6 exists on path from 4 to 6, but like 7 is not less than equal to 6. So this is not a valid pair. And if we look at these two conditions again, what it says, like there is no comparison of U over here. Only thing it says is like if you start a path from U and look at all the paths or all the W's V, you should count the number of nodes which are greater than U on this path. No, basically which are greater than V on this path. So first let's do the reverse thing. For each V less than W, let's find all the paths from V to W over here. Like for example, like this can be the path. Like for example, this is one of the path in the tree. Like there can be other nodes hanging over here. Then you can notice that for all the nodes over here which are hanging to W over here, like you can add +1 for these U and V. Like because if you take any node from this, you will take a part to V and there would be W in between them. Sorry for the screen. Like let's first ignore U and look at all the V less than W. Like let's say this is a path and like there are, let's say, other nodes hanging on it. Then for all the nodes which I have marked as green, like probably I will do it again. Like let's look at all the V less than W. And let's say like for all the paths, like there is a path like this. There are other nodes hanging on all the places. Then for every node on this side, we can add +1 due to this pair V and W path over here. Because if we take any node from here, say this one, then on this path, like W will exist which is less than V over here. So like this is the first idea. Like instead of looking at U, let's look at all the pairs and add corresponding count to each of the numbers. So now the next idea is, like, let's look at V somewhere. Like there is some tree hanging over here, some tree hanging over here, some tree hanging over here, and some trees which are hanging to the parents. Then we can count the number of nodes which are less than V in this card. Let's say 3 nodes. three nodes are greater than v in this path. Like let's count the number of w's over here. Let's say like there are three nodes which are greater than v in this path. Let's say there are two nodes greater than v in this path. And let's say there is one node which is greater than v on this path. And let's say there are five nodes which are greater than v on this path. Then like let's look at the total count. Like if we look at v in isolation, there are five nodes greater than v on this side, three on this subtree, two on this subtree, and one on this subtree. And what we can do is like 5, 3, 2, and 1, the sum is 11. Then we can add 8 as an answer to it, which is count of these. We can add 9 as an answer, which would be count of 3, 1, and 5, all the remaining ideas. And we can add 9, we can add 10 as the count on this subtree, which is 2, 3, and 5. So basically everything on V except this one. Like that was the main idea. So like now we have first reduced the answer to counting the number of nodes in each subtree which are less than V. And then like for each subtree hanging at V, like some paths can be coming from parents and the other path something can be coming from each subtree hanging at that node. And for each node we take the sum of everything except that particular hanging node. And like if we do it for all the nodes and if we keep adding on all the subtrees over there, we would be able to get the final answer. Now like one thing, like this gives an idea of rerouting DP, and like finding this count would be like these counts can be easily maintained using small to large streaks. Like finding this count would be a bit tricky. So what the idea I have used over here is like we know that all the nodes are between 0 to n or 1 to n. Like so we know that there are total v nodes, v minus 1 nodes less than v in the complete tree. So instead of counting this, like I can count this 3, 2, and 1, and like I can subtract it from v minus 1. This will give me the number of nodes which are less than v in the parent tree. Like that was one trick which reduced a lot of subtree DP idea, like rerouting DP. And once you have done this, now you can use the subtree sum queries. There are many ways. Like you can definitely use Euler tool. And the neat idea I did was like if I want to add something like let's say u, this is the root. I want to add something to this subtree. I have added some value over here. If I want to add something to this, then I have added some value over here. If I want to add something to everything except the subtree of u, then I have added that delta over here and subtracted that delta over from v. So at last we can take the prefix sum from root to that node to find the final answer. Like I will jump on to the code and like if something is not clear, I can try to explain it again. Like a first DFS where I am maintaining an order set PVDS set so that I can count for each u, like in the each subtree which is hanging at you, like how many nodes are less than you. The idea is you can run it in the child and run child.order by query to find that subtree node. And like we can add that to everything except this node X over here. And like then small to large merging. And then we want to find with the parent, like since it's zero based index, I know that like the number of nodes which are less than u in subtree of u, and u, if you subtract that u, then we will get that for the remaining parent. And I have added that everything to the subtree of u idea, like that was the idea. And then like prefix sum from root to that node and print that as an answer. Like any questions on this one? Like I would like to jump on bi-weekly as well. So like if there are any questions, I can take that as a comment. Like do post something in the comment, and I will try to answer that if something is not clear. And thanks everyone for joining, and like see you.